This video is about the properties and the area of trapezoids. A trapezoid is a quadrilateral with one pair of opposite sides parallel. The parallel sides are called the bases, and they are not congruent. The non-parallel sides are called legs. They can be, but don't have to be congruent. And the leg angles are always supplementary. This is a pair of leg angles. The two angles on the same leg. Okay, so this would be another pair. All right, so the mid-segment of a trapezoid is the segment that connects the midpoints of the legs. All right, the mid-segment has two properties. It is parallel to each base, and it is the average of the bases. So the mid-segment is, so if I called this the mid-segment, this was base 1 and this is base 2, it's B1 plus B2 divided by 2. All right, let's do some examples. So my first example, we're going to find EF. So I know that it is the average of the bases, so I'm going to add them together and divide by 2. All right, and that average, let's see, is 21.5 divided by 2, which is, okay. On this next example, I need to find one of the bases. So this is my B1. Okay, so I have 23 is the average of B1 plus 28 divided by 2. All right, so we solve for this, and we're going to get 46 equals B1 plus 28. Subtract 28 from both sides, and I get that B1 is 18 units. So we have a special kind of trapezoid, and it's called an isosceles trapezoid. An isosceles trapezoid is one in which the legs are congruent. It has two more properties. Both pairs of the base angles are congruent. Okay, so remember we have our base, and then the two angles on that base are going to be congruent. So here's our other base, and then these two angles that are attached to that are congruent. The diagonals on an isosceles isosceles trapezoid are also congruent. Okay, so if I drew them in, these two little segments would be equal, and these two little segments would be equal. Of course, they don't bisect each other, and this is still an isosceles trapezoid. And the intersection divides them proportionally. Okay, so let's look at a couple of examples that are isosceles trapezoids. All right, find each angle. So I know that in any isosceles trapezoid that the leg angles are supplementary. So I have 180 minus 50 is 130. And then because this is an isosceles trapezoid, I know that both of the base angles are congruent and both pairs of base angles are congruent. Okay, so here's my pair of bases, and so this angle right here is 118 as well, because the base angles are congruent, and then I do 180 minus 118 to get 62, which means the other base angles are 62. Because I knew I could do that because these two angles are going to be supplementary. Here's a couple more examples before we do the area. All right, so I know that this is the trapezoid, and we're going to find the measure of angle x. And so it is also a 28-degree angle. And that's if this is isosceles. Okay. We're going to assume that this next one is also isosceles, and we'll be able to solve. So I want you to notice this triangle right here. Okay? And so we'll be able to find that missing angle. If this is 15 plus 45, so that would be a 55-degree angle here. We know this is 40 degrees, and so now we just have to find that angle. So we take 40 and 55, and we get 95, and we're going to subtract that from 180, and that gives us 85 degrees for x. Okay, another example with our isosceles triangle, and isosceles trapezoid. Okay, so KB is 21.9. FM is the whole diagonal, and it's 32.7. Find FB. So 32.7 is the whole thing, and we want to find FB. Okay, so I'm going to put an X right there. So I know that if it's isosceles, and it is, that these diagonals are equal. So if the whole thing is 32.7, and KB is 21.9, this section right here is going to be the same as the X value, and the two of them together are going to add up to the 32.7. So I have X plus 21.9 equals 32.7. Subtract both sides by 21.9, and I'm going to get that FB is 10.8 units. Okay, so let's find the area of a trapezoid. So we have our trapezoid formula. It's pretty much similar to a parallelogram, but since the bases are different, we have to average them together first. So instead of just base times height, we're going to do the average of the bases times the height. And so that's what I've got here is two different ways to write it. Okay. You might be used to seeing it look like 1/2 h, B1 plus B2. Okay, that's the way that I typically write it, but it makes it understandable. We take the average of the bases first, and we multiply it by the height instead of like the rectangle or parallelogram. Okay, so remember the height is perpendicular distance between the bases. It's not necessarily the length of the bases, or it's not necessarily the length of a leg either. All right, let's do the first one. So the area is half of the sum of the bases, 18 plus 40, times the height. Okay, so I have half of 58 times 15, which gives me the area is 435 meters squared. Okay, let's do the next one. Again, we're going to do the area is half the sum of the bases times the height. So I have half of 50 times 16, which ends up being 400 feet squared. And one more. Notice that this is the distance between my parallel lines. It is perpendicular, but even though it's outside, it's still perpendicular to the line that contains that base. Remember that the bases are the parallel sides. And so we're going to do the area is 1/2 the bases added together times the height. So it's not always the top and the bottom. Okay, and now I have 1/2 36, which is 504 yards squared. Okay, so let's look at this here. Ryan runs a landscaping business. A new customer has a trapezoidal-shaped backyard shown at the right. How many square feet of grass will Ryan have to mow? If Ryan charges $5 for 100 square feet, then how much should he charge the new customer? All right, so first we're going to find out the area, and then we'll find out how many, what he's going to charge. Okay, so we're going to do, the area is 1/2 times the sum of the bases, so 20.5 is the same as 20.5. So that's this one. And then this is plus 5 and 5 plus 10 more, so that's 30.5 times 38.25, because 1/4 is the same thing as 0.25. All right, so we have that the area is 975.375 feet squared. Now, we want to see how much money he would charge. So if Ryan charges $5 for 100 square feet, let's see how many hundreds of square feet we have. So we'll take this 975.375 and divide by 100. And so we have 9.75375, and we're going to multiply this by 5. And it's going to give us, because that's $5, 48.7688. So we'll say he would have to charge $48.77 for that yard. One more example problem. Isosceles trapezoid RAMS with bases RA and MS has the following coordinates. R is at -3, -3. A is at -3, 5. And M is at 3, 8. Find the coordinates of point S and the area of the trapezoid.